Let me do this integral by 4 methods. Now the first method, I multiply the numerator and the denominator by secant x. So I multiply secant on the bottom, which is a secant x and then plus 1, right? And the numerator is actually d secant. Right? The numerator is the derivative of secant. The denominator is secant x plus 1. And the derivative of secant and the derivative of secant plus 1, no difference. Therefore, this is equal to natural log secant plus 1 plus c. Now it's been done. That's method 1. Method 2. Dx 1 plus cosine x. I multiply the numerator and denominator both by a cosine. So tangent times cosine is sine. This 1 times cosine and plus cosine square by the low rule. And then this is equal to sine x dx is the derivative of cosine negative, right? Negative. This is a cosine x 1 plus cosine. Now obviously that I can bring a new variable that u is equal to cosine x. Then my integral is equal to negative du and u 1 plus u. Very good. Then this is equal to negative, and this is obviously by partial fractions, right? This is a du, and I omitted the detail of the. So this is equal to u 1 plus u, right? This is 1 plus u minus u. This is 1, this is 1, right? Yeah. So this one is equal to, this integral is a negative log u plus log 1 plus u, right? Plus c. So the integral has been done. We just plug u back. U is a cosine x. So this is a natural log positive is 1 plus cosine x over x. Yeah, that has been done. This is a second method. Now, third method, tangent x dx 1 plus cosine x I multiply both top and bottom by 1 plus 1 minus cosine. So tangent x 1 minus cosine x dx, and for the bottom we will want the same thing, right? 1 plus cosine x and 1 minus cosine x. And then the denominator is obviously the 1 minus cosine square. This will be tangent minus sine. Yeah. And this will be, the denominator will be sine square. And this will be sine over cosine for tangent minus sine x dx. So we can have two parts of integral. The first one will be integral the first integral is a sine cancel out, so it's equal to 1 sine x cosine x, minus 1 over sine. Okay, good. Then the first part of integral is equal to this will be 2 sine x cosine x 2 dx. That's the first integral minus integral cosecant x dx. So this will be cosecant 2x d2x. 2 dx is this. This will be cosecant 2x minus cosecant x dx. And this one will be natural log cosecant 2x minus cotangent 2x. And this will be natural log cosecant x minus cotangent x plus c. If you put them together, that will be cosecant 2x minus cotangent 2x over cosecant x minus cotangent x. So this is the result by using the third method. The fourth method, this is tangent x 1 plus cosine x dx. Now I'm using this method, right? Let t be tangent half x. Now you must know this method, right? We just change x into t, and let me develop something where you don't have to memorize those conversion of a sine x, cosine x, and a dx, and so on. Let me do this way, all right? T is equal to tangent half x. So therefore, my triangle is that this angle is half x. This angle is half x. This is t, this is 1, right? This is 1 plus t squared. And first the sine, okay? Sine x is equal to twice the sine half of x cosine half of x, right? So the sine x is t over this, 1 plus t squared. Cosine is 1 over 1 plus t squared. Therefore, sine is 2t over 1 plus t squared, see? And the cosine x is equal to cosine square half of x minus sine half of x. So this one equal to cosine is 1 over 1 plus t squared minus, this is t, right, over square, that's t squared. So this one is equal to 1 minus t squared, 1 plus t squared. See, we have a cosine. Now then, how do we have a tangent? Tangent x is equal to 2 tangent x, 1 minus tangent square half of x. So this is equal to 2t and 1 minus t squared. See? Now finally we have a dt. We take a derivative both sides. So dt is equal to tangent is secant square half x times half, right? So this is equal to 1/2 secant square. Secant square is this is square, right? So this is 1 over 1 plus t square. Okay. dt dx, I'm sorry. This side is dt, this side is x. So this is dx. And from which we can find a dx. Dx is equal to no, this is wrong. Secant is this over that, right? So this one is equal to 1 plus t squared times half dx. So dx is equal to 2 dt 1 plus x squared. Alright, so we have this. We have a tangent. We have a cosine. We have a sine. So you don't have to memorize. You don't have to memorize the conversion of these functions. So just in case you forget, you can derive by using this method. Now I have a tangent x is 2 t over Okay, 2t over 1 minus t squared. And the dx is 2t. No, 2 dt. 2 dt over 1 plus t squared. And the cosine is 1 minus t squared over 1 plus t squared. See, then we simplify, we get this cancel with that one, this 2, so end up with 2t dt 1 minus t squared. Okay, this one is equal to 1 minus t squared negative d 1 minus t squared. Yeah, so this one is equal to negative natural log 1 minus t squared plus c. Then we plug t back. T is half of x, right? Half tangent x. So it's a negative 1 minus half x. Here, that is a result by fourth method. So I have done this integral by 4 methods, but we get 4 different answers, you know. Well, we have a different form of the answer. Now I want to verify that they are equivalent, you know, they are the same. These two are easier. Now 1 over cosine is secant. Cosine over cosine is 1. Therefore these two are equal. No difference. Now let me do this one first. I want to verify this one is equivalent to this one or that one. Now this negative I can put it on here, right, to make it reciprocal. So it becomes a natural log 1 over half x, right? Yeah. This is good. Now this negative goes there and it becomes reciprocal. And this one is equal to, I multiply cosine square half of x. So this is a cosine square half of x minus sine square half of x, right? Yeah. And then this one is equal to natural log the bottom, the denominator, this one is equal to cosine, right? This is cosine x. Yeah. This one is equal to 1/2 1 plus cosine x. So this one is equal to natural log 1/2 times 1 plus cosine x over x. So this one is equal to natural log 1/2 plus log 1 plus cosine x over cosine x. That means this one is this. This log 1/2 is a number. This number can be combined with c, right? Therefore, this one and that one they are same. These two are same. Log half is just combined with C. All right. So these two are equivalent. Now finally this one. This one. This is 1 over sine 2x. This one is cosine 2x sine 2x. Right? This one is 1 over sine x minus cosine x over sine x. Right, so this one is equal to natural log 1 minus cosine 2x over sine 2x over 1 minus cosine x over sine x. Okay, then this one is equal to log well, the numerator 1 minus cosine 2x is what? Is equal to sine square, right? Sine square x over 2. Is it over 2? Yes. No, times 2. Sine 2x is a 2 sine x cosine x. That is the numerator. Times the denominator. Denominator is the sine on top. 1 minus cosine x. Yeah. This one's the natural log. Yeah. This one is equal to 2 cancel out. So cancel with the sine and cancel with the 2. Give the sine square cosine. 1 minus cosine is 1 minus this is sine square, right? No. Keep 1 minus cosine. Sorry. It's confused with. Okay, then sine square is 1 minus cosine square. This is cosine. Yeah. And over 1 minus cosine x. Now this is 1 plus cosine, 1 minus cosine. Cancel with this one, so this is equal to natural log 1 plus cosine x and over cosine x. So that is the same as this one. Yeah. So eventually that they are the same. So I did this integral by 4 different methods, and also verify that the results are the same. Now this integral is not really difficult, but this example showing 4 methods is a really good exercise for those who are taking the basic calculus course. So it's a good example to practice. Thank you for your watching.